Like, for example, on the robotic side, R1, implanting those threads. How difficult is that task?
Yeah. So as you mentioned, they're very, very difficult to maneuver by hand. These youth arrays that you saw earlier, they're actually inserted by a neurosurgeon actually positioning it
Hmm.
near the site that they want, and then they're actually there's a pneumatic hammer that actually pushes them in. So it's a pretty simple process, and they're easy to maneuver. But for these thin film arrays, they're very, very tiny and flexible, so they're very difficult to maneuver. So that's why we built an entire robot to do that. There are other reasons for why we built the robot, and that is ultimately we want this to help millions and millions of people that can benefit from this, and there just aren't that many neurosurgeons out there. Um, and robots can be something that we hope can actually do large parts of the surgery. Um, but yeah, the robot is this entire other sort of category of product that we're working on, and it's essentially this multi-axis gantry system that has the specialized robot head that has all of the optics and this kind of a needle retracting mechanism that maneuvers these threads um, via this loop structure that you have on the thread.
So the thread already has a loop structure by which you can grab it.
Correct.
Okay.
Correct.
So this is fascinating. So you mentioned optics. So there's a robot, R1. So for now, there's a human that actually creates a hole in the skull. And then after that, there's a computer vision component that's finding a way to avoid the blood vessels.
Mm-hmm.
And then you're grabbing it by the loop, each individual thread, and placing it in a particular location to avoid the blood vessels.
Mm-hmm.
And also choosing the depth of placement, all that kind of
Correct.
stuff. So controlling like the 3D geometry of the placement.
Correct. So the aspect of this robot that is unique is that it's not surgeon assisted or human assisted. It's a semi-automatic or automatic robot. Once obviously there are human component to it when you're placing targets. You can always move it away from kind of major vessels that you see. But I mean, we want to get to a point where one click and it just does the surgery within minutes.
So the computer vision component finds great targets, candidates, and the human kind of approves them. And the robot does it do like one thread at a time, or does it do?
It does one thread at a time, and that's actually also one thing that we are looking at ways to do multiple threads at a time. There's nothing stopping from it. You can have multiple kind of engagement mechanisms, but right now it's one by one, and we also still do quite a bit of just kind of verification to make sure that it got inserted. If so, how deep? Did it actually match what was programmed in, and so on and so forth.
And the actual electrodes are placed at differing depths in the it's very small differences, but differences.
Yeah.
And so that there's some reasoning behind that, as you mentioned, like it gets more varied signal.
Yeah, we try to place them all around 3 or 4 millimeter from the surface, just because the span of the electrode, those 16 electrodes that we currently have in this version, spans roughly around 3 millimeters. So we want to get all of those in the brain.
This is fascinating. Okay, so there's a million questions here. If we go zoom in specifically on the electrodes, so what is your sense? How many neurons is each individual electrode listening to?
Yeah, each electrode can record from anywhere between 0 to 40, as I mentioned, right, earlier. But practically speaking, we only see about, at most, like 2 to 3. And you can actually distinguish which neuron it's coming from by the shape of the spikes.
Oh, cool.